Hello, in this lesson we will be considering lines and classifying pairs of lines as parallel, perpendicular, or neither. You'll be looking at graphs of lines and also equations of lines. Let's get started. We'd like you to finish each sentence so that the statements are true. And these are your options that will help you finish the sentences. Take a moment and consider which option will best work for each sentence. Then we'll check. All right, coplanar lines that are parallel have the same slope. Coplanar lines that are perpendicular will meet at 90-degree angles. Coplanar lines that are neither parallel nor perpendicular will eventually intersect at one point. Sometimes you see that point of intersection. Other times on the graph you won't see it, but you will know that they intersect if they're not parallel and they're not perpendicular. So we'll go on to this frame where we have to sort the graphs showing pairs of lines as parallel, perpendicular, or neither. And I would just say that the ones that are neither parallel nor perpendicular are a little bit harder to spot. If these lines were parallel, then they would both be purely horizontal. But these are not parallel. They're also not perpendicular. While they will eventually meet, they will not meet at right angles. These lines here are also neither parallel nor perpendicular. You can spot the two parallel pairs of lines, right? There's one pair and here's the other. And the remaining sets of lines are perpendicular because they will intersect at right angles. Lines A and B shown on the coordinate plane are parallel. Write the equation of each line. Use any convenient form of the line, slope-intercept, point-slope, or standard form. So we got you started here with line A. And what I decided to use for line A was the slope-intercept form of the line. And the reason I use that is because my y-intercept is very clear. It's -1. And my slope, I can measure it as rise over run between these 2 points or between these 2 points. Now you might be wondering, is there another way to write that? There is. I could do y equals 1/3 x minus 1. So you can either say plus -1 or you can say -1. All right, now line B, the y-intercept is not clear. It's some fractional value, right? Some decimal value between 2 and 3. So when that happens, it's better to use the point-slope form of the line. And we can use the same slope of 1/3, right? Because these lines are parallel, up 1 to the right 3. You can use either point as your x1, comma y1. I'm going to use this point as my x1, y1. So when I substitute those values into my equation, I'm going to remember that my equation always starts with y minus y1 equals m times x minus x1. So let's go ahead and type in that equation. Now y minus this y value of 3 is equal to your slope, 1/3, times x minus this x value of 1. So that's one possible equation for this line. There's another equation that we could have used. And the other equation would have used my x1 would be -2 and my y1 would be 2. So that would also work. Just want to point that out to you. You could have said y minus 2, right? That y value is equal to 1/3 is your slope times x minus -1. Oh, excuse me, x minus -2. Remember, whenever we have minus and negative, we can rewrite that as plus. So that's the second form of the line that would be equivalent. In the next example, we want to write the equations of these perpendicular lines, and both of the lines have a clear y-intercept. So let's use the slope-intercept form for both lines. See if you can write those equations, and then let's compare. So for line C, did you say y is equal to -3 over 1, or just -3x, plus 4? So this line is decreasing. Its slope has to be negative, down 3 to the right 1. For line D, my line is increasing. It will have a positive slope, positive 1/3 x, and my y-intercept of line D is -1. Notice, if you will, when lines are perpendicular, their slopes will be opposite reciprocals. So this slope of -3 and this slope of positive 1/3 are opposites, and they're also reciprocals. With that in mind, we can sort pairs of lines as either parallel, perpendicular, or neither. Now remember, parallel lines are going to have the same slope, right? So when we look at lines with the same slope, these are all in slope-intercept form with one exception. There's a pair of parallel lines. They have the same slope. Now, before we classify this pair of lines, let's rewrite that top equation in slope-intercept form. Let's subtract 2x from both sides. Now that we've done that, we can see that these lines are actually parallel because they do have the same slope. Alrighty, so then we can look at lines that are perpendicular, and these slopes are going to be opposite reciprocals. One is positive, one is negative, and the fractions are flipped. So these lines are perpendicular, and the slope of these lines are negative reciprocals, so these are also perpendicular, leaving us with neither for both of these. And I know this was tricky because you probably wanted to say perpendicular, but remember, they need to be opposite reciprocals. So if this line has a slope of 4, this one would have had a slope of -1/4 for it to be perpendicular. Now we'll move on, and we would love for you to write about the big ideas about slopes and equations of parallel and perpendicular lines. And if you want to play around with any of these tools to help you illustrate your ideas, feel free. If you want to use your pencil tool, you can do that. Or if you just want to start writing what you know about slopes of lines that are parallel and perpendicular, feel free to do that. Thank you.